Welcome back, ladies and gentlemen. Today we will be working on week 1, day 3, so Wednesday, of our countdown to FSA. So the first question says, write a numerical expression with exponents to describe the sum of 3 times 3 times 3 times 3 and 36. So there are 1, 2, 3, 4. So we're going to say 3 is my base, 4 is my exponent. And it wants me to write it with exponents. And it says sum. So sum tells me I'm adding. And then it says and 36. So I got to think of a number that is going to get me, or a exponent that's going to get me 36. Well, I know that 6 times 6 is 36, so I can say 6 squared. There may be more for this one, but as long as your exponent right here, or your base and exponent, equal 36, then you should be fine. And it says an expression, so it doesn't need an equal sign. It's not asking me to solve. For number 2, Gavin drank 3/4 of a liter of orange juice from a container, which was 3/8 of the orange juice that was originally in the container. How much orange juice was originally in the container? Well, for this problem, if he drank 3/8 of what was originally in the container, we know that my answer is going to be a larger number than 3/8, because 3/8 is pretty small, and we know if he only drank 3/8 of the container, he didn't even drink a full half. So we know our answer is going to be larger than a half. Well, let's write an equation here to help us solve. So if I have 3/8, which is what we know which was 3/8 of the container, times the amount of juice he drank that we don't know, equals the 3/4 that he drank. So here I'm going to solve. Divide by 3/8, they cancel, divide by 3/8. Now again, this is called a complex fraction when I have a fraction over a fraction. Remember that a fraction bar just means to divide. And I'm going top down. So that means I need to write it out, 3/4 divided by 3/8. Well, I know when I'm dividing fractions, I have to keep, change, flip. Keep the first, change the sign, flip the second. When I do that, I can cross simplify, and cross simplify here. 4 goes into 4 one time, 4 goes into 8 two times. So I get an answer of 2. Is 2 more than a half? Yes, so we can assume our answer is wrong. If you accidentally replace these two and put 3/4 here and 3/8 there, you would have got an answer of a half. Well, you should have known that was incorrect, because he drank 3/8 of the container. So he almost drank half of it already, so there can't be only a half of a liter in his container. There ended up being 2 full liters in his container. The next one, I'm dividing. Dividend, divisor. Divisor's on the outside of the box. Dividend is on the inside of the box. Remember, I like to have numbers above here. So, how many times does 3 go into 1? It doesn't. How many times does 31, how many times does 31 go into 1? No times. How many times does 31 go into 10? It doesn't. How many times does 31 go into 107? Well, we can do that. Let's try 31 times 3. Gives me 3. That gives me 93. So let's go 3 times 93. And I chose my number because I know that 3 times 3 gives me 9. And I know that 90 was close to 107. So subtracting, getting 4, 1. So 14. Again, I'm thinking 3. How many times does 3 go into 14? Well, if it would go in 12, that'd give me 12. So let's try 31 times 4. That would give me the 12. So we got 4 here and 124. So let's say 4 times 124. Subtract 4, 2. 24, bring down the 8. Okay, I know that 3 times 8 is 24. So let's try 31 times 8. That gives me 8, 24. Looky there, there it is. That's an 8. So my answer is 348 for that problem. And again, it's zeroed out. Let's look at the next one. So we're multiplying decimals here. So when we multiply decimals, we don't need to line them up. 307 decimal. In my problem, this one has 2 spots and this one has 3 spots. So I know my answer is going to have a total of 5 spots that I'm going to need to move my decimal. 3 times 3 is 9. 12, carry the 1. 6, 7. Cancel, cancel, cancel. All these are zeros. Now, because I have 2 x'd out here, I'm going to have 2 zeros down here. 7 times 3 is 21, carry the 2. 28, 29, 30, carry the 3. 14, 15, 16, 17. When I add that up, I get 9, 2, 8, 0, 7, 1. How many times did we say we needed to move the decimal? 5 times. 1, 2, 3, 4, 5. So 1 decimal, 7, 0, 8, 2, 9. That's what I'm saying my answer is for that. So for the last one here, it says there are 72 boys and 90 girls on a math team. For the next competition, Mr. Johnson would like to arrange all the students in equal rows, with only girls and only boys in each row. What is the greatest number of students that can be in each row? Well, it says the greatest number. When it says that, it tells me that I'm looking for the GCF of these two numbers, or the greatest common factor. So here's my numbers, 72 and 90. Okay? So I can start on either one and go back and forth. Well, 1 times 90, 2 times 45, 3 times 30, 5 times 18, 6 times 15, and I can keep going. But let's ask ourselves, do any of these numbers go in to 72? Does 90 go into 72 evenly? No. Does 45? No. Does 30? No. Does 18? Yes. 18 times 4 is 30. So our greatest common factor here is 18. So the greatest number of students that can be in each row is 18. Okay guys, again, this is week 1, day 3 of the countdown to FSA. See you guys tomorrow.